Dobar dan, everyone. Can you hear me? Thank you for having us. It's a pleasure to be here. My name is Filip, and I'm very happy to share this stage with my dear colleague Luka. He's been with us at Superology for over 2 years now, and he's our tech lead. And pretty much from day one, he's been driving us forward. Wants to improve the app both for us and both for our users. Pretty much because of him, we are currently... No, it's okay, it's Superbet colors. No, I can talk without it. Okay, great. So, because of him, we are currently refactoring pretty much everything in our app. And that's why, naturally, everyone hates him.
Yeah, and Filip, he's our Android team lead. He's been with the company for more than 4 years now. And he's the one who thinks that everything's perfect and that we don't need to refactor anything. And that's because I hate him. So jokes aside, we're both really good colleagues in Superology, the company behind this conference, behind SuperMinds. And we in Superology, we drive and innovate Superbet's digital ecosystem, where one of the key parts of this ecosystem is our Superbet mobile app. And this is the app we are going to talk to you about today. It's past, present, and future. And since Filip has been with the company longer than I have, I'm going to let him to break the ice and tell you a bit more about the past. Here you go.
Thank you, Luka. So the reason behind our talk is that we would be interested in hearing your experiences about your apps, the problems that you have and solutions that you came up with. That's why we enjoyed yesterday's Ivana's talk when she went us to a journey over their app. And at some point, it's going to sound a bit like we are bragging, but that's just because we are proud of what we accomplished. But also, we're going to talk a lot about mistakes that we made along the way and the problems we have. So let's start. You see on the top of the screen, there is a timeline. So I'm going to take you for the past, to the present, and Luka will join me later for the future part. And that's what you see here. That's our first product app. So we started to working on it in 2017. And back then, things were quite different, you can imagine. So even the company had a different name. Back then, we were called Score Alarm. And we had a quite successful white label application that we ran across the whole Europe. So around that time, we began to conquer the Romanian betting market. And that did not go unnoticed by Superbet. That is, and that was and still is, the leading betting company in Romania. So we noticed that we share the same passion for development and for mobile apps, and we decided to work from them exclusively. Our app is, at first it was sports statistics, but then later we introduced sport betting into it, and then even later we introduced social components. So it's like one-stop shop for everything you need with betting and social. And but that time, in 2018, it was a great time to start from scratch. It was our transition from agency company to a product company. So we decided to start scratch with our Android project too. And the first thing you do when you start from scratch is that you copy everything you have from your old projects into a new one. It's a great fresh start. So we did. We copied everything, and everything we had before was Java code, so it seemed logical that we continue to write code in Java. And so our first project was a single module Java application with no dependency injection, pretty much no architecture. Our first version was released in September of 2018. And our second version was released half an hour later, of course. So you can say that we were quite agile at that time, although we did not have any agile kind of development methodology. We had what we like to call the favor-based development, where each product manager had its favorite developer, and the developer had its favorite designer. So you pretty much do a feature as a favor to someone who asks you nicely. We're still not agile, but we have a bit more complicated process now. I'll talk to you about later. So as the time passed, we kind of noticed that we now need to live with this app. We need to maintain it. And we started to work on another project, so we added the shared module, so we don't have to copy everything again. So let's say we are learning from our mistakes already. At that time, Kotlin became official supported language by Google, so we start to write everything in Kotlin. We even added dependency injection. We go with Dagger. We added some MVP architecture, or some sort of MVP architecture already had. So we started on the right track. We added some very cool new features. We hired some new people. We drank some beer, and times were good. Although, over the time, we noticed that it became harder and harder to do those features. It took us longer and longer to implement even the simple stuff. And took us longer and longer to bug fix things, to fix bugs. So I remember from that time, there was 5 of us at a time at the company, and we spent more than 2 days debugging the issue with the app, where it just randomly stopped working and then start working again after some time. And after 2 days, it was one-line fix. And from that, we learned that we don't really know RxJava as well as we thought. Yeah, but no one does, so it's OK. And later, in 2019, Corona came. And when you are in sport entertainment business, pretty much everything stopped for us. We were stuck at home, and we were start to thinking about some strategy. How can we improve our app? How can we make our lives easier? So we started thinking about architecture. We started to think, how can we support multiple teams in app? How can we support multiple flavors? And we started to think about modularity. So after a couple of Zoom meetings, we decided that it's a great time to start again from scratch. But this time, we did not copy anything. So we really did start from scratch. And it is what we call the birth of our V2 project. So everything we had before was, let's say, V1, and then a brand new start in our V2 project. And we had to decide where do we want to go from there. We decided to stick with MVP architecture to improve it a bit. We decided to stick with RxJava, and we decided to migrate our dependency injection to Coin. And at this point, you may ask me, why? Why did we make those decisions? What was the reason? Well, I don't have a straight answer to that. We make those choices because at that point, we worked with those technologies before, so we kind of knew what we're doing. We did not want to step outside of comfort zone. It may not have been a great decision, but those decisions were made at the time. And after some time, in those times, we were stuck at home, so pretty much we lost track of time, of course, but after some couple of months, it went great. We wrote like a bunch of new code, we refactored a bunch of new stuff, and I expected we just need a couple of more months and we're going to refactor everything. We're going to release this brand new version to production and no one's going to notice. But since a couple of years have passed and we're still not done, you can say that I was a bit wrong. And we are not done, but we are close. We are still doing it, and we are on a good path, of course. And the only good thing here is that all those new stuff that we wrote, all this new code, we actually managed to release it in production. It's not that we're just having it somewhere, because we managed to integrate all that new stuff, new code, into our old code base. And one of the main reasons why we managed to do that is because we introduced modularity to our app. And now, Luka is going to talk to you a bit more about modularity, how we've done it, and why we've done it. Luka.
Thanks, Filip. So if you take a look at the timeline at the top of the screen, you can see that we have slowly progressed towards the present state of our app, of our product. And one of the key things which actually got us there, or here, how you take it, is modularity. So in the next couple of minutes, I'm going to tell you why we introduced that modularity in the first place, how we did it, and what challenges and benefits it brought us. So first, the why. As the product grew, the company and our Android team grew as well. So Superbet app was now much more than just an app to place a bet. You could also take a deep dive into the sports statistics related to the bet. You could use the wallet to virtually store the funds which you're going to use for placing bets in the future. You could also enjoy various social aspects of the product, like chatting with friends and commenting on a game, sharing your tickets on the newsfeed, copying tickets from your friends from the newsfeed. So naturally, the company wanted a way to be able to better scale, develop, and maintain those different segments of the product. And we decided to do that by dividing into specialized units, which we call verticals. And you can imagine a vertical to be like a mini company within Superology, responsible for a segment of the product. So sports statistics vertical is going to develop and maintain sports statistics features. Betting vertical is going to do that for the betting features, and so on. And each of these verticals should have the autonomy to grow independently as it wants, how it wants, and its own team of dedicated designers, QAs, POs, data analytics, and of course, developers. So backend web, iOS, and Android. And the challenge for us in the Android team was, how are we going to adapt to this new vertical-based organization system, both in team and technical aspects? Of course, we accepted the challenge. And the team part was obviously pretty easy. We decided to divide into verticals as well, where now each developer is only working on one vertical. So if you're part of the sports statistics vertical, you're only going to do sports statistics features of the app, which is great because there's no context switching and you're able to fully grow and breed and integrate with your vertical. But the tricky part was actually that technical part, or our code base. It was already hard enough for the team of 5 or 6 people back then to work simultaneously on the same code base. And the introduction of verticals didn't really help there. So to make our lives easier, we decided to divide our code base into verticals as well, or to be technical, to divide it into sub-modules. And this is how we did it. Now, the code base of each vertical will get divided into these 3 sub-modules. So the UI, for layouts, themes, UI models, custom views, and so on. The API for API managers, API models, networking in general. And the app submodule for all that Android stuff, like activities, fragments, view models, and so forth. And just trying not to mistake this app submodule for the Superbet app, it's just a name we decided to give to the submodules where we're going to put our Android stuff. So now, each vertical will have its own set of these UI app and API submodules. So there's going to be one for the stats vertical. There's going to be one for the betting vertical, for the social vertical, and of course, each other vertical in the app is going to have its own set of these submodules. So for instance, all of our sports statistics, fragments, and activities will get placed into the stats app submodule. Betting fragments into the betting app submodules. Stats themes into stats UI submodules, and you get a point. And they all together make our Superbet app. But I guess you see an issue here. How are we, for instance, going to put some betting component on a stat screen, since there's obviously no dependency between verticals? Lucky for us, there's a main module in our project, and he's the only guy having the knowledge of each and every vertical in the project, sorry, each and every submodule in the project. So we are now able to utilize this main module in order to establish a communication channel between submodules of different verticals. Let's take this screen for example. It's really blurry, but this upper part up there, Real Madrid and Leipzig, I believe it says so,
This is a betting component, and it's placed on a stat screen in our application. So how are we going to do that? Since having app-to-app submodule dependencies is obviously not allowed, our stats app submodule would ask our main submodule, hey, could you provide me with this data? I need it for one of my screens. And it's going to do that using an interface, which is extremely important. And since our main module knows where it can get this data from, it will say, yeah, sure, I can do that. I will take a look at our betting app or API submodules. I will get that data for you. And eventually, it will return it to stats. Now, we have our data, but somehow we need to place it on the screen. So AKA, we need a piece of betting UI. Since having app to UI submodule dependencies is allowed, that part is actually pretty easy since we can just borrow our betting component from the betting UI submodule. Currently, we are having over 35 submodules in our project, where the team of 10 people is working on 9 verticals. And when you open Android Studio and take a look at our project menu, it sometimes looks scary, especially if you take in the fact that we are having over 200 fragments in our project. Or at least I thought it was over 200. This morning I took a look at Android Studio and we are close to 300. So from that perspective, having our code base divided in this particular structure is, in my personal opinion, one of the best things we've done so far, because it really enabled us to do things well and independent per vertical. Even though it introduced some challenges, like having to establish that communication between submodules of different verticals, which always presents us with constant increased complexity while trying to communicate between them, it actually brought us much more benefits. So for instance, if I'm working something on my stats vertical code base, and if I break something, I won't affect anything happening on the betting code base or the social code base, and so on. Also, if an external code base wanted to use our stats features or our betting features, it would be, in theory, easy to do that, because we would just plug that set of UI app and API submodules into that external code base, since the connection is done using interfaces. From the product perspective, extremely important, we are now able to have completely different design languages to use completely different APIs and technology in general per vertical, which all leads to the conclusion that now each vertical is truly able to grow independently, as it wants, how it wants. But since now each vertical can do things in its own way, so develop features in its own pace, I don't know, release it when it's ready, and so on, the final question is, how on earth are we going to release something to production when each vertical can say, oh yeah, I'll do it this in that way, and I'll do it in that way. So we had to create a release process which will conform to this idea of having verticals growing independently. And that's where Filip comes back in play, because he's one of the guys who helped us do that. So Filip, the stage is yours.
So before you have any release process, pretty much you release an app when you have something worth releasing. So when you have some cool new features you want to show your users, or when you have some critical bug fixes you want to release to production. And it worked for us until it didn't. Until we started to have more and more verticals, so those, when you have something worth releasing, became more and more often, because when you have 9 of those, pretty much you have something worth releasing all the time. So we had to introduce a release cycle where we would release an app every 3 weeks. And of course, we did not invent this. We borrowed it from Spotify, when they call it release train. which Edis explained yesterday. So the first thing that we need to do is we needed to change our mindset. And when you need to change your mindset throughout the whole company, it's not that easy, right? So we needed to change our mindset from thinking, let's create a feature and then release it on 1st of December, to thinking more like, let's create a feature, let's brainstorm it, develop it, test it, and then we're going to release it when it's ready, when everybody is pleased with it and when it is the best it can be. That's why it's called release train, because if you miss a release train, there's always next one in 3 weeks. And this brought us great benefits, because now we could release the small bits of our code, the small bits of our feature, and then test it, and then use the data to see if it's something worth releasing or abandon it or adjust it to the data. It also enabled us to release only high-quality stuff, because we are not releasing something until it's really ready. You're not release something just because you promised someone. You release when the product team behind that feature is pleased with it. So it works pretty much like this. Every 3 weeks on Thursday, we create a release candidate. So we create a release candidate for everything that is at that point ready for production. We worked until that Thursday, we worked for that release, and right until that point, we start to work for next release. So development does not stop. We send that release candidate to our QA engineers, and they test it. They run a whole bunch of automatization tests and scenarios on that build. There are now more than 100 of those. And it was very important to do so, because since we have around 300 different screens, it would be very impossible for them to go over each and every one by hand each time. So that automatization process that they have is pretty important. And it's quite fascinating. They're here over here in the second row, so you can ask them later about it. They will be happy to share their experiences with that. And so they run all their tests, and they report issues back to us. We fix those issues, and in the 10 days, yeah, of course it's going to happen. And in 10 days, we are ready for release. So release that into production. Thank you. And to support this release process, we needed to adjust our Git flow too. So our Git flow consists of 2 main branches that runs throughout the eternity, and they are protected. You cannot push to those directly. So we have develop branch and release branch. And development process starts when you create a feature branch from your develop branch. So each developer in each vertical will start working on a feature, creating a branch. If it's a longer feature, he would even create more branches from there. So we will have like smaller pull requests, easier to review. When the feature is done, we merge it back into the develop. And when I say done, I mean when development is done and the feature is tested, because the QA engineers are part of the development process. Yesterday, someone asked if our QA engineers work only those 10 days. Well, as a matter of fact, they don't. They work full-time, so they are part of the development process, and they work from discovery throughout the whole development, and when something is merged into develop, it's already tested. So when the RC day comes, we are just merging everything that we have at that point on our develop branch to the release branch. From the release branch, we create the release candidate 1. The QA engineers run their tests, and they report issues back to us, and we fix those issues on our release branch. Everything that we fix, of course, we need to merge back into the develop, so the fixes are applied also for the next releases, and we create the release candidate 2. And on the production day, we just take the latest release candidate and publish it to production. We are not doing that until all 9 verticals, all 9 product teams gave us green light. So each product vertical had its own QA engineer, and when each and every one of those QA engineers gave us green light, we are ready for production. I would be proud to say that we managed to release candidate 1, but that never happened. So at least 2 are needed for production. As I said, all that time, the development process goes on. So while we create the release candidate, the QA engineers test it, the vertical product teams are still continue working on new features, something that might be ready for the next release, and the development process continues. And all those processes that I've talked about and all those submodules that Luka talked about enables us to have a small pull requests, easy to review. But it's also enabled us to have more than 200 of those per month. So in order to make this right, we needed to create all sorts of documentation or some naming conventions, architecture guidelines, code style guidelines, so that every developer knows what is expected and what is required for something, some code, to be merged to develop. And our DevOps teams have also enabled us to use GitHub Actions. So we have like night builds that run every night, so all those automatization tests are run automatically. We have ways to create those release candidates with just one click. And all that is automatically published to our internal systems where all artifacts are stored, so it's easily accessible throughout the whole company. And this brings us to the present, and then to the part where I can brag a bit. So there was like small team at the beginning, like 3 confused Android developers, has now grown to like 10 confused Android developers now. And the company grew from like 10 people when it all started to more than 100 now. So we grew from a small office to a small apartment to a huge office now. Our Android app is now available in both Romania and Poland, and we have some new exciting markets coming up. And it's available on the Google Play and Huawei Store. We have more than 500,000 monthly active users, and our Google Play Store is around 4.5 stars. And when our customers usually gave us 1-star rating when they lost a bet, it's not that easy to maintain a good store, but we are proud of our 4.5 rating. Sorry. And most of our code is now rewritten in past year or 2, so that's great. Yeah. We have all those processes that are working well for us. We have our customers that are happy. So you can say that everything is perfect now, right? Well, ta-da. I think that Luka has something to add.
Yeah, thanks, Filip. I completely agree that many things have been done quite well. We have well-established processes and workflow. But since we are a product, we have to make sure to stay up to date with the current technology standards, which is something where we still had a lot of work to do. And if you again take a look at our timeline, you can see that we have slightly progressed towards the future. And that's because all the things I'm going to talk about now are something that we are still currently working on. And even though we have made a significant progress there, we are still far from applying that on the scale of the entire application. As Filip mentioned, 5 years ago or 4, how long was it? We decided to go with MVP, Android View System, RxJava, all that stuff. And just by looking at our current tech stack, we could all agree that it could use a little refresh, right? So we could, for instance, switch our old MVP architecture for MVVM architecture. We could replace Android View System with Jetpack Compose. We could do the same for RxJava and introduce Kotlin coroutines. And it really made sense to do so, since our codebase was already almost 100% Kotlin and fully reactive. So going with that MVVM and Compose route seemed right up our alley. And we decided to do so. So over a year ago, we created our MVVM skeleton. We educated ourselves about Compose and about some new technologies. And we started coding In the meanwhile, we managed to develop more than 20 new screens, which are highly complex, really big screens. And we noticed that something was like really wrong. And that was the fact that we couldn't easily reuse certain components from our old MVP architecture in our new MVVM architecture. And from the product perspective, this MVP architecture was actually really good. It supported the product growth for nearly 5 years. It enabled us to develop new features fast and to easily maintain them. But that's all in this MVP vacuum, which is not really something you want from the technical perspective. And why we failed there? What was the reason? It's actually pretty simple and pretty basic. So you know all those things we're often talking about, like clean code, solid principles, design patterns, and so on. Even though we thought we knew them, it turns out that we didn't. And when there was a challenge in our code base, we lacked the knowledge of, I don't know, for instance, design patterns. And instead of doing the things in the right way, we improvised, and it actually created the tech debt that we're dealing with now. So our new way, where we are heading now, is called general reusability, and we want to turn our tech debt into tech profit. So the next couple of slides will show you how we were breaking all those clean code guidelines in the past, let's call them so, and how you can do like just little improvements to make your code much better, and that's not absolutely not something new or revolutionary or mind-blowing, but for some reason we all often fail to comply with those guidelines. So surprise, surprise, first of all, it's single responsibility principle, which states that each class, module, or a function in a program should only have one purpose in a program. And in our architecture, there's a component we call a mapper. And the mapper basically takes in data and metadata inputs and converts them to some UI models. And usually we created a mapper per screen. So if that screen consisted of next match, team standings, and the legend component, we would put all that code for creating those individual UI models in this one mapper class, which is like really bad. You can't reuse that code, you can hardly test it, and it's extremely bug prone. So much better approach would be to immediately extract that logic for creating those individual components into smaller mappers, inject them into our screen mapper class constructor, and just use them to create those individual UI models. And the things here are good now, because our screen mapper is only like assembling this UI model wrapper, but the logic for creating those individual components is placed in those smaller mappers which are injected. So the code is now much more reusable, it's much easier to test, and it's much more bug-proof. Second thing is try to be as architectural neutral as possible. When you do so, you'll be able to connect components of your application like little Legos. And I have another example for that. So in our app, we want to provide our users with certain browser functionalities. And we have a couple of those browser screens where each is slightly different, but they all do that browser stuff. So someone in the past had created this base browser fragment component, which you just basically extend. You don't have to do any browser-related work. You treat it as any other fragment, and you're good to go. But about a month ago, I think, Filip was working on a new screen, and he created it using our old MVP architecture, even though we have started using our MVVM architecture over a year ago. And why was that so? It's because this base browser component wasn't architecture blind, and it conformed to that MVP structure we had in the past. So one way to approach this better would be to extract the signature of this base fragment logic into an interface. Let's say all it does is it initializes a web client and a download listener. So if we extracted this logic into an interface, then we could simply implement that interface in any fragment class and delegate the implementation to a browsable class, which is good because now every fragment can be browsable regardless of the architecture. And remember those little Legos I mentioned earlier? So if in the future we decided that some browser fragment need to have some location capabilities as well, we could repeat the pattern. So create a locational interface, implement it as well, and delegate the implementation to our locational class. So that's just one way of approaching this better, and it all comes down to the point that you should always favor composition over inheritance. Next, you want to eliminate cross-cutting concerns. So that's something happening on the application scale. It's present on the application scale, but it will affect your individual components, so the individual layers of your architecture. Let's say logging analytics. You can log analytics in your view model, in your view controller, in your repository, whatever the use case is. And that would, again, break our single responsibility principle because that view model or view controller or repository already have a responsibility of their own. That's why you should always make your components conform to a certain interface, because in that case, it's actually pretty easy to dynamically add behavior to individual objects without affecting the behavior of other objects from the same class. And that's actually something called decoration. And since it's a bit complicated to explain that in a minute or two, feel free to catch me after this talk in the hallway and we can talk more about it. So in general, always try to work with abstractions instead of working with classes directly. So as I said, this is nothing new or revolutionary or mind-blowing, but for some reason, we often fail to comply with that. And we did so too in the past. And that's why we have like this new approach to how we make things today. And you can sum it all up in 3 key points. So we're currently at the most future part of our timeline, and that's because, not because this is something far distant or something hardly feasible, but something that will always make you much more future-proof. So you should always keep on learning, and not about the latest and greatest things from the Android universe, but also about some things which are, let's call them eternal, like those clean code guidelines and everything related to that. Once you've done so, you'll be able to question and evaluate, which is extremely important. So for instance, if I come to one of my colleagues and told him or her, hey, just do that like that, that's good, or I don't know, if I gave him some advice or instruction, this advice should never be taken for granted without evaluation and without questioning it, because how will you know that you're doing things in the right way if you can't evaluate them? So we often have a situation in job interviews where certain candidates solve our task. And when you ask them, okay, so why did you do that in this particular way? And they answer, well, I don't know, it's because we do it like that in our company, which isn't necessarily bad, but you should know why you're doing that in this particular way. And last but not least, make sure to always leave the comfort zone. So we failed to do so a couple of years ago. We opted for that, let's call it old tech stack. But now we're thinking much more differently. And even though if we decide to apply certain technology in our project and we fail, that's also okay, because you also learn something from that failure. So when you combine all of that together, you'll be able to future-proof yourself, your code base, and your product in much more better way. And that's pretty much it. That's what we wanted to say. So thank you for your attention. I hope that you learned something today, that it was fun. And now the Q&A.
Hi.
Hello.
So my first question would be regarding the tech stack, because you mentioned that you started with Dagger, but then you migrated to Coin. Do you plan to migrate to Hilt, and do you have tests, unit tests per screen, per layers, like API layer, data layer, etc., to verify coin behavior, because coin is not actually a dependency injection, it's service locator?
Well, if I can start, I don't plan to migrate, but Luka might.
He's always positive.
It's good. It works.
I don't plan to do it too, because we have a lot of screens in the app, and it's hard to do that now. Yeah, we do write unit tests, and we write them for that mapper component you saw on the screen, and for our interactors, so for our repositories. And there's a thing we do unit tests for. So if we develop a feature, and the QA has tested it, and we have merged it into develop. So let's say, for instance, we have a match detail screen, which is like a really big screen, and you have, I don't know, 30 entry points to that screen. It's hard for a QA engineer to cover all that by just, I don't know, doing manual tests. And that's why we have those automations, which our QA engineers are going to run in that testing period of our release cycles. And that's actually something which we are relying on, that will detect potential coin failures, because they really do have a lot of those scenarios, and they can test various things happening on that screen, which are not necessarily related to that single feature, to that new single feature that we introduced to the screen. So I hope that answers your question.
Yes.
Great. Another one? Yeah.
I'm going to throw it, okay?
Yeah.
I talk here, right?
Yeah.
Okay, so why did you decide to go with the separate modules or packages or whatever for UI and app? What's the decision there? So usually we are used to having the, let's say, UI domain and API. You have UI and app and just API.
Well, we don't have any particular reason, right? But now it enables us to have those small merge requests. That's what we got out of it. As you said, it doesn't make sense to have just UI components without the API. So we don't have, if we want to plug that in another project, we'll probably take all three of those that Luka showed you. But when you have more of those, it enables us to have smaller merge requests, so it's easier to review them, and it's easier to follow what's going on in a certain product vertical.
Yeah,
Does the API then contain the domain logic and the core of the application logic?
Sorry, I just quickly wanted to return to that UI question also. When you saw that communication channels between different verticals, it's easy to provide data like that. So if a bearing vertical uses some bearing data, then we can get that data using our main module, which is going to map it to some models which our stats vertical knows about. And you can't do that for, let's say, custom views. How are you going to map your custom view class? That's the reason why we decided to put that UI stuff in a separate submodule, because having those app to UI submodule dependencies is allowed, and stats app can have a dependencies to bearing UI, and bearing app can have a dependency to bearing UI, so there won't be circular dependency there. So that's why we decided to extract that UI layer to separate submodule. And could you repeat the last question, please? I forgot.
So the API stuff, API submodule, does it contain all the logic, all the mappers, or are those part of the app? So I'm really interested in how did you split those? We now know how you split the UI part. What's the split between app and API?
Okay, so basically those mappers, which you saw earlier, are part of our app submodule, because you need to convert certain data to UI models, and that data doesn't necessarily need to be something which you got from the API. So for instance, current state of the metadata on the screen, let's call it so. So I don't know, you have a couple of tables on your screen, and you decide to expand one of those tables. You somehow need to keep that information about the expanded tables. So we keep that information in a subject which we also observe along with that API data, and then Mapper can just use all of that and map our UI components, UI models. We also use protobuf for our networking models, and our payloads are like huge. So the models we receive from our backend sometimes contain like hundreds of fields, and we do have use cases in certain scenarios where we reduce those API models to something smaller, which our mapper is going to work with, since it might not need that whole model. But basically, that's the reason why we decided to put that mapper component in our app submodule.
So last question, I promise. Basically, so that means that communication between different modules via the main module runs with, I don't know, asking those mappers to do stuff? Or
Yeah, of course. So, for instance, that bearing example you saw there. So our main module is going to get the data using bearing API submodule, and then it's going to map it to a bearing UI model using some bearing mapper which is placed in the bearing app submodule. And then it's going to return that UI model to our stats vertical. That's the flow.
Yep. Thanks.
No more questions from you. Another one? Here?
Hi.
Yeah.
Where does your navigation logic lives in?
Sorry,
Your navigation logic, let's say between UI modules and...
So we don't use that navigation components from Jetpack, but we have something similar. So we implemented something that in the end was like similar to that Jetpack Compose stuff, but each of those submodules, verticals, the UI has like some enumeration where we have all the list of all available screens, but just the enumeration. And then we navigate throughout the main module. So you say to main module, okay, navigate now to that screen, and then the main module finds the fragment that you want and create an instance. In that way, we literally have the only one place where you call fragment new instance. So we don't have that around all the way, so we need to, let's say, add some arguments or something. We need to refactor it in just one way.
Yeah, and also we have factories for screens which belong to a certain vertical in the app module of that vertical. And when you decide to navigate, you are also going to do that using an interface. You're going to say to your main module, hey, I want to navigate to that screen. And you're going to use that enumeration that Filip told you. And the main module is then going to reference our screen factory from a concrete submodule and use it to create that fragment instance. And the main module is actually the one who's going to make the navigation there.
Yeah, it's very cool because you can like literally code navigate to function with having a base fragment from anywhere in the app, and it's going to navigate to anywhere else in the app, regardless of those product vertical.
And how many activities do you have?
2, 3.
Yeah, I think it's
we have
3.
like main activity, which contains like button navigation that you see, and then we have one activity that we call single fragment activity, just like activity for everything else. When you navigate away from main screen, you lose the button navigation, and then it's like fragment container where we have our fragments. We may have like something, we have splash activity, of course, for splash, and we have link handling activity for deep linking into the app, so with the logic there without the UI, just the activity.
Yeah, I think it's about
I am
3 activities, yeah, and close to 300 fragments.
Thanks.
Somebody else? Yeah, this side.
Hi. Regarding the UI models you use, for example, on betting, use data from the stats model, right? But for example, if any other model is using stats data also, so do you have any duplicated data on other models that use that stats data, for example? Or, because you create always the UI models for that model, right? So is there any duplicated data there?
No, since if you wanted to show that betting component on your stat screen, you would place that betting data, which is now formed via that betting UI model, into that betting UI component. So when you, for instance, from your stat submodule want some betting data, you're going to ask the main module for it. It's going to retrieve the data, I don't know, from some API or something, and use the mapper from the main submodule and map it to the betting UI model, and return that UI model to your stat screen. And then you can like borrow that UI component and just bind that UI model to the component. And of course, if we just need that data to make some internal stats calculations, and we don't want to show some particular betting component to the user, but we need the data for some reason, then it's going to be mapped by the main module to an equivalent of that model which came from, what was it, the betting, yeah, to something stats knows about. So of course, you're going to have duplicates there, but I don't know, that's the way it goes. Otherwise, we could create some models and which would be shared and put them in some common folder, but that would break this whole point of modularity, and we wouldn't be able to use that set of stats submodules somewhere else if ever needed. So we have those duplicates if that was the question.
Yeah.
Okay.
Yeah, okay. Thank you.
We're also going to notice that it's not working what just got me in a couple of years. So we have a version 3 of our app. We're going to notice that all that we talked about here is not working for us anymore. So we're going to have another refactor, another start from scratch. But that's for our next talk.
Great.
Boxes.
Anybody else?
Hey,
Box.
can you hear me? Yeah. Box is at me. This is the questions row, so I'm just...
Okay.
My question is, do you have some transfer of databases? You used MVP there, and then you're switching to MVVM. Probably you used SQLite, some manager or something. Now you're switching to Room or some ORM. Or?
Yeah, we actually have only one database in our app, and that's just for analytics. So we like store analytics and then send it in bunches, and when the time comes. So we did not have to migrate there. We had some SQLite, but I just deleted it and no one noticed. And, so we have one Room database for now. We store a lot of our stuff in the small stuff we store in preference,
Clever.
shared preference, and we also store everything in a memory that we need for that session of the app.
Yeah, not offline, right?
Yeah, it's not an offline app. It cannot work because of the betting, so
you don't have
you're lucky
sync
there.
issues.
Exactly, you don't have the coefficient, so there's no point in like storing the data locally.
Yeah, okay, thanks.
Maybe one practical question people are embarrassed to ask. Do you hire new people? I'm asking for a friend.
Yes, as a matter of fact, we do. So yeah, you can...
We didn't practice this.
Yeah,
It
we
just
have
happened.
a whole bunch of people from our People and Culture office here that can help you with that. Over there, over there.
Anybody else? Or we should close with this thought.
Yeah, let's go with this.
Yeah.
Thank you very much.
Thank you so much. Yeah.
Thank
you
you.
can be the host. One big round of applause. Thank you, Filip and Luka.